All right, let's talk about mixtures. Recall from the definition of chemistry. Chemistry is the study of matter and the changes it undergoes. And matter can be classified into two broad categories: pure substances and mixtures. Pure substances are things like elements or compounds. And we have spent an awful lot of time focusing on pure substances in general chemistry. Elements are the things on the periodic table, one of the elements at a time, one of the types of atoms at a time. Compounds contain two or more elements. So an example of an element would be sodium or hydrogen. Even though it's diatomic, it's still considered an element since it's just hydrogen. Examples of compounds would be sodium chloride or water. We have a definite formula for them, and they are considered pure substances. We have talked a little bit about mixtures. Mixtures come in two varieties. They're either heterogeneous or homogeneous. Heterogeneous mixtures do not typically mix completely, and we don't spend a whole lot of time in general chemistry talking about them. Homogeneous mixtures are things that are usually classified as solutions, and we've already spent some time talking about solutions in Chem 1, and we're going to pick up where we left off. But we're going to focus a little bit on these homogeneous solutions, these mixtures of substances, which is one of the types of matter, and some of the properties of it in terms of things that we have just learned about pure substances. All right, let's start by talking about gases. If I have a mixture of gases, these will spontaneously mix. Gases will, if you put two different gases in a container, before too long, through the process of diffusion, each of the types of gases will spread out into the container, take up the container, just like the other gas wasn't there. We learned about this in the gas chapter. So these will spontaneously mix, and they will mix completely. The reason why gases spontaneously mix and ideal gases behave as if the other gas isn't there is all about intermolecular forces. Recall that in the gas phase, the particles are very far apart, and so any intermolecular forces between the particles are very weak or not existent at all. In other words, the gas particles do not interact. According to the kinetic molecular theory, if you have an ideal gas, those particles do not interact, and so essentially they're behaving like the other one isn't there because there's no force acting upon each other as well as the other gas, and that's why they will spontaneously mix. If you are looking at samples of liquids, whether or not two liquids will mix depends. It depends on what the two liquids are. And we have a general saying for whether or not two liquids will mix, and that saying is like dissolves like. Things that are like each other will dissolve in each other or mix with each other. For liquids, if two liquids do mix together, we say they are miscible. If two liquids do not mix, we say they are immiscible. All right, so liquids that are miscible do mix, liquids that are immiscible don't mix, and why do they or don't they? It depends on whether or not they are like each other. And by like, of course, we mean their intermolecular forces. If the intermolecular forces between the particles of each substance separately are similar, then they will mix. And recall that the intermolecular forces are things like London dispersion forces, dipole forces, and hydrogen bonding. And we can kind of generalize this. This is very much a generalization, but it works pretty well with some exceptions. If you have two substances that are polar, a polar and a polar, they tend to be miscible. Two substances that are polar would have dipole intermolecular forces as well as London forces. They do tend to be miscible. If you have two nonpolar substances, then again they tend to be miscible because they have similar forces. If you have a polar and a nonpolar, then they tend to be immiscible because they have different forces. There are gray areas, there are gradual changes between whether or not a polar and a nonpolar will mix. There are lots of sort of gray areas in here, but at a first glance, in general, we can use these generalizations to get a quick guess as to whether or not two liquids would be miscible or immiscible. All right, finally, we want to talk about mixing a solid in a liquid. And you've already actually spent a lot of time talking about this. These are our aqueous solutions we talk about in Chem 1. Anytime you put a solid substance in water, you have an aqueous solution. Although we don't have to be talking about water for our liquid, that is a common liquid we use for these types of solutions. The same kinds of things govern whether or not a solid will dissolve in a liquid. Like dissolves like. All right. We don't use the words miscible and immiscible for solids and liquids. You may recall that we use the terms soluble and insoluble. Soluble means it does dissolve. Insoluble means it doesn't dissolve. And again, like dissolves like, so things that have similar intermolecular forces will dissolve in liquids that have similar intermolecular forces to it. And this is one of the reasons why ionic compounds so readily dissolve in water. Ionic compounds have ionic forces because they're ionic. Water is a polar molecule, so it has dipole forces as well as London forces because it's covalent, but it also has hydrogen bonding, which tends to be the strongest of the intermolecular forces in general. And so these forces of hydrogen bonding between the water molecules are similar enough to the ionic forces of the ionic compound that these do tend to dissolve in each other. We know it's a little more complicated than that because we learned in Chem 1 there are some solids, ionic compounds, that do not dissolve, that are insoluble, and we look at the solubility rules to govern whether or not solids will dissolve in water. But in general, again, there are some gray areas, there are some exceptions. In general, like dissolves like, and so if you're looking to see whether or not a solid material will dissolve in a particular liquid material, if they have similar kinds of intermolecular forces between the two of them, then you can guess that they would tend to dissolve in each other.